Hey everyone, and welcome to your first lesson in Chapter 3. So we're going to start Chapter 3, Section 1. Get yourself ready for notes, and we're going to get started. Today we're going to talk about graphing polynomials, and we're actually going to spend this whole week talking about graphing polynomials. We're going to start today's lesson talking about factored form, and we'll continue to standard form, and then of course using our graphing calculators. So there's going to be a lot of vocabulary in this set, because we're going to talk about all the different points that I will judge your graphs on, and that you should judge your graphs on to make sure that they're being accurate. We're also going to make sure that we're all on the same page in terms of the definition of the term polynomial. So a polynomial is a sum of monomials. So sum is when we are adding them together. And a monomial is anything that is a number, a variable, or the product of the two. So anything that you think of as like 3x squared, that would be a product. So for example, something, as I said, 3x squared, but it also could just be the number by itself. 7 is a monomial, as is y. Now, something that's really helpful in terms of graphing polynomials is thinking about its degree. Now, if we remember, our degree is the largest exponent present in standard form. So standard form is when we have like ax squared plus bx plus c, so not factored. And we're going to look at factors right now, but that's all right. So one thing that we will see is we'll talk about the degree here. We can tell the degree in a graph like number 1 or 2 by observing the behavior and observing the factors. So here, we'll start by thinking about the degree. And the degree would be, we've got x in the first term times x in the second and x in the third. These are the highest degrees of each factor. So then the highest degree in total would be them all multiplied together. So the leading highest degree term would be x to the third and then be plus something, something, something. So our degree for this one is 3. Now, the degree is important because it affects what's called the end behavior. So what happens to the graph at the end? So for a parabola, for example, the end behavior is that they always end up either both pointing up or they end up both pointing down. Right? This is how a parabola works. And that's because a parabola has an even degree. If it's an odd degree, either there'll be one pointing down like this, or it'll be in the opposite direction. And there'll be some sort of, wiggling something in the middle. Now, these two possibilities, we tell them apart because this is if the leading coefficient is positive. It'll look like this, where either if it's even, they both point up. If it's odd, it goes in an upward slope like a line. And if they're both pointing down, or it goes down like a negative slope, this means that it's got a negative leading term. So if I look at my leading term here in number 1, my leading term is x to the third, which tells us it's degree 3, and it tells us that our sign is positive. So since we are looking at a positive, so we're in this column, odd, we know our end behavior is going to look like this. We're going to have one arrow pointing this way on one side, something happening in the middle, and the other one's going up like this. So that's really helpful. The next thing that we're going to talk about are our intercepts and our roots. So if I'm looking at for my intercepts are just where a graph meets an axis. And so we can have y-intercepts and we can have x-intercepts. Our x-intercepts are also called our roots. They're sometimes also called zeros. So the way that we can calculate our x and y intercepts is that our x-intercept is wherever y is equal to 0, and then our y-intercept is wherever x is equal to 0. So wherever one of our variables is equal to 0, that's the intercept for the other one. So if I come back up here, this is always an important point. We want to look at our y-intercept is usually the easiest one for students to remember. So our y-intercept in standard form is the lowest is our constant term, and that's true here. So we're looking for the constant in a polynomial, but it's also sometimes easier in factored form and also other equations, because constant doesn't always mean, it doesn't always work in other types of functions. It only works for polynomials. So we're just going to say it's where x equals 0. So in this case, x equals 0, if we plug that into our function, we get 0 times 0 minus 2 times 0 plus 3. Well, that becomes 0 times negative 2 times 3, which is 0. So our y-intercept is 0. So that tells us another point that we're going to go in here. So we've got something in here. We know we're going to have an arrow pointing down on this side and up on this side like this. What else is going to happen? Well, we need to find our y-intercepts, or our roots. And our roots are where y is equal to 0, or in this case where the whole function is equal to 0. And this is why it's nice to start in factored form, because it's already factored for us. So in this case, just like if this was a factoring problem, if we've got 0 is equal to factors, it's just where each factor equals 0. So 0 to negative 3. Whoop. Those are the roots, the 0 for each factor. So here we've got negative 3 as a root and positive 2 as a root. Once we have all of these filled in, so we know its degree, we know its sign, that tells us our end behavior. We have our roots and our y-intercept. We can start filling this in. So this is going to come up like here, because we're going from here, it has to go through this point. Now it has to eventually come back down and then back up, because they must cross through, they must go through those points like so, and there's no other roots. We found all the roots. Hopefully this makes sense in going through this process that you can do. So we'll talk about degree, sign, y-intercept, and root. Let's look at another example, and this has an important idea, which is called multiplicity. And so the idea here is that some roots are going to have a multiplier or an exponent. So this is what we think of as the exponent on the factor for the root. So for example, x minus 2, the root for x minus 2 is positive 2. So if I'm looking at some factor x minus a, any exponent it has is its multiplicity. We're talking about this number here. Now, up until now, we've only seen odd. We've seen it to the power of 1, because we don't write that. So if it's odd, it's going to behave just like what we've seen before. If here's the x-axis, the root's going to either just go through it like this, or it's going to go through it like so. If it's even, however, it's going to, what I call this is bouncing. So it's either going to come up, and instead of going through, it's going to go back down. So it just touches the x-axis, and then if it's above, it's going to bounce up like this. So easy way to remember this is that if it's even, it looks like a parabola. If it's odd, it looks like a line. So when I'm going through number 2, my leading term here is negative x to the 6th, negative x to the 4th, times x. So my degree is 6, which makes it even, and the sign is negative. So our end behavior is going to go pointed down both at the same way. Our next thing, as we discussed, is our y-intercept, which is where x is equal to 0. So negative 0 to the 4th times 0 minus 2 times 0 plus 1. Again, we've got this multiplier of 0, so our y-intercept is also 0. So once again, we have a lovely point through the origin. And lastly, our roots. And we have our roots 0, 2, and negative 1. So here and here. And what's important is that this has an even multiplicity. So this one at 0 is either going to go up like this, or it's going to go like this. And the question mark is just which side of the axis is it going to be on. Well, we're going to start from our endpoints that we drew in. And this is going to go through, come down, and again, so it's coming from the top, so we're looking at this, where it goes back up, and then it comes back down. Obviously, this is a rough sketch of a graph, but it absolutely would, if you check it on your graphing calculator, it would have this same behavior coming from the bottom, small bumps, and then going back down. If you have questions about graphing in factored form, please don't hesitate to leave something in the comments or set up a Zoom meeting, and I look forward to hearing from you all soon.